out. So we will work on the input and output sector, and to uptime this, we will have a network for this. So now just I play the video, my famous video to start with, and then we'll go one by one how the causal AI is different from others. So I'll play the video for you, have a look at on the video, and there will be some questions. Please answer my questions because it is not too which you can understand how it can be done. So the traditional AI method, what is the problem in the thing which we have to implement, that we're going to share with you, right? So hopefully you have seen this movie. I'm going to play the video of this case study using this movie. You know about this, have a look at it and just tell me what is the logic which has been there, and from then we can arrive this what you call like a causal AI, how it has been derived and how it has been related with that, right? Right. So now just please watch this. Actually, we have this video for you. And after that, we can go for a solution. What is happening? And then we'll have a questions. Now, like this is the scene, and from this we are going to derive what is all to be done. The exact problem in the scene, actually, what exact problem in the scene? I've already told, like it is to identify the human from the group of robots, actually. So, can you anyone tell me what is the exact problem or fine tune the problem here? Guys, please be interactive, actually.
Then before that, so inhale and exhale, so body movement, chest movement, based on that.
Then any other answers? Any thing. So just can you tell me any other fine tune the problem actually? Anyone else? The first and foremost thing is that is an act as an input for you, right? So this is the data set, and in this case we have 100 robots as the input data sets, and output is very simple to identify the human. Simple. Human identification. That is, it identifies in the robots group, right? But the problem, real problem which comes across here is, right, everyone is same. This is the problem. So here we have to identify the mechanism. You to identify the data that is different of data from the same group. This is the problem what we have. Same group, we have to identify the human or a scientist from the group of same robots. This is the exact problem. If there is a problem, like what you can like do is, if there is there is a 50% of robots and 50% of human, it can able to same. And from the same data, it has to identify the difference of the data. This is the logic. So this is the exact problem what we have now. Now the logic which comes across here is, let me go for it. Now, what are the features? Now that robots has been done with the help of different features. It extracts the bodies, it scans your body, and you can see there will be the breathe rate. Will be the breathe rate control system. You would have seen that the robot, that is the human, has controlled his breathe actually. Sweat is being controlled and checks whether the blood comes out of the body. And finally, like this is what the logic is. Rotation of head. This is the logic which we have. So these are called as the features. This is all called as the features. And these features are extracted and it is given for the machine to train it. Now, just can anyone tell me, for identifying this kind of robotic application, my question clear? I told you what makes the different ML and DL. So can anyone tell me, like, for this scene, whether it's ML is ML? Okay, then any other answers? You have only two answers. The above, and then we can have none of the above also. So all the above, we can go for all the above as a case. ML, okay, ML, DL, ML, right? We have ML as most important choices. Why ML? Any justification? I have got two answers, actually three answers. You can answer this is the question, like, why ML? Because you can say, like, dealing with the machines. Not the case. You're not dealing with a machine. You have to instead, you have to check with the data. Here you have data as robots to be designed. When you go for a version of 2.0, then we can go for a DL. So that makes the difference. So here it doesn't mean that dealing with a machine, the data what we have. So hopefully you can clear with that, right? So, but the thing is, with a mathematical formula. Now, let us go for the data model, how to design a data model, and then we'll go for an application. Now, the robots are given as an ID. So we have to identify robots ID. Body scan name it as a 1. If the body scans as a metal, you would have seen in the movie, the body scans as a metal as 1, will be considered as a robot. If it is 0, then it is considered as a human. So body scanning 1, right? Since it scans only a metal for the robot. There should not be any breathe. Robot doesn't breathe. But there should not be any sweat. I make it a 0. And there should not be any blood. But the robot can able to rotate is considered, but there may be some values. But for your understanding, for the easy understanding, we'll have this body scan. If it scans the body, if it finds a metal, it is 1. If there is no breath, it is 0. And there is no sweat, it is 0. And there is no the robot can rotate the head for 360-degree. So I named this as a data. Now, my thing is how my learning model understand this is a robot. So that we go for a label. So that is the logic. So that we go for a label. That is an output. So that is the label mechanism. That is why we go for a label. One zero 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 one. That is metal body, no breath, no sweat, and no blood. With the head can rotate up to 360-degree. I label this as 1. So this is the logic. And a breathe, there is a sweat, and there is a blood, but the human it as a 0. This is the supervisory learning. This is the topic which we have in supervisory learning. So supervisory learning is something like which we are making out in these cases. So the supervisory learning is nothing but where the inputs and outputs are again here it knows what is the input and what is the output. These are all the inputs and these are all the outputs. So if that is the known, then it is known to be the supervisory training model. If only one supervisory and unsupervisory. Supervisory, I repeat, input and outputs are known to the model, then it is called supervisory model. This is the logic, right? So now we'll talk about the outputs here. This is the inputs and there is an output. The and second is most important is called prediction and is regression. We'll talk about this regression in the end of the things. Hopefully this scene will give you the classification. Been done with the help of a classification. Prediction is not here because it predicts based on the gathered data. It predicts what is going to be happen. So that is the weather forecasting and everything that has been designed, right? I'll give you the prediction what has been there with an example. Right? And the prediction, I'll just give you an example. Happening over here, I'll just give you an example. It predicts actually. This is the prediction because the based on the inputs it predicts who has came over here. So now these are the inputs which has been defined. For example, let Talavar says, I'll just explain you. We have come across, we have solved with the help of a probability theorem, which you would have studied on the morning or you have been listening on the morning. So you can see this is all the probabilities which is occurring that there must be a person, right? So this is a logic. So it doesn't directly it predicts there is a human, nothing like that. It predicts the human on the series of incidents what we have. It's series of data what we have, right? So this is something like we call it as a prediction. This is an example of a prediction based on the data what we obtain. We are going to predict what is going to happen, right? And that is across here is next is the most important case what we have right now. The case what we have is regression. So now the regression is more. I'll just explain you the concepts actually, right? Hopefully you can understand what is the difference to now. Can you understand what is what? Is it clear? As you can even make it in a message actually whether the topic which has been clear actually. So why we go for, because have. So the input and output in between the model is going to be trained for the input and output is going to be obtained. And there the output depends upon the output. We have three categorization. One is classification, prediction, and the human from that. This is one kind. And the second kind is prediction. Based on the data what we so supervisory, what is supervisory and supervisory, difference between ML and DL. It's all okay, it's clear. And why this probability, I told you where it is. This is the probability. It assumes the probability where and what and how. Based on the probability, it decides what has been happened, right? So okay, now we'll go for the most important cases between DL and ML, right? I'll just repeat here. The ML, you can go for an ML. When you go for a huge data to be processed, you can go for a DL. The second important difference is like the feature extractions and other things which we have to do as an extra cases, which the ML doesn't have. This and then you have to link with the ML. But whereas in the deep learning, the feature extraction is a part of a deep learning. It is not a separate part. So that makes the difference between these two. So clear right now? Yeah. Now just I'll move on to this. What is the logic which we are going on here? Hopefully you can see my screen. So classification, prediction, we just made it over here. Now what is the logic here is, now I just go for this. Now these inputs, only these inputs, based on the outcome. The outcome doesn't depend upon this. These are the input. These are the conditions which has to be satisfied. If this condition satisfies, like what is the output? Want to have the relationship between the inputs to obtain the outcome. That is your outputs. So each we have right now. And if this is the case, we call this as simple causal A. So what happens when this causality happens in between the inputs? This is what we are going to study. The relationship, establishing the relationship between the inputs. We have the For example, the outcome is designed. For example, the students, when you want to train the students, you will consider a lot of parameters which is interlinked with each other. So that is being taken as an input, train the model, and based outcomes. Now I'll just discuss with you with a basic example, and that example is based on this theory. Just explain with this actually, right? This is the basic example which is there. Make it very sure about it. So we are going to do the case study. Right? Have you seen this movie? It is not a technical question, guys. You can answer this. Have you seen this movie? Simple. Yes. So I'll just explain you, elaborate you the things which is happening, and then you can go for it for the basic understandability of this. So now this is something like the film starts. I'll explain you the film, and then we'll just make it into the model. 12th century in between the Shaiva king versus Vaishnavism, where in the ocean, right? This was the case. This is the basic input, right? I'll just make it out. This is in the ocean. This is the logic, right? This is the case, right? So this was the first we have. Let us assume this is input number one. I'll just name it what is what, right? Input number one. Now, this the climax, that is your outcome. Something movie. This movie is nothing but it clears. It makes that virus is destroyed. Simple. So this is the logic. So makes that virus come. That is your outputs, right? Two, that output, overall output. Now, who is been working on the bioweapon, right? Input number two. And there will be the conflict, and this bioweapon will be coming to India. And this, after that, will be changes, will keep on changing its hand. That is the series of incident, input 4 and input, let us say up to input 5. finally the virus is released. Incident, because there will be the cases where the Vishnu idol which was been thrown into the ocean movie, right? So now the logic which comes into the picture is these are the series of inputs. Input number 1, 2, input number 5. And from this, the outcome is obtained. So now the logic is the relationship between all the inputs based on A, right? Plus regression. So what happens? The series of inputs here, the inputs are fixed. Not in this case. This is not the case. Here there will be a relate of each and everything. For example, let us case these input 2 will have some other businessman will keep on keep on the input is arrived. That is, the bioweapon comes to India. So this is how the logic comes into the picture. This is how the logic comes into the mechanism which has been there. So this is the logic which we have to understand the logic. So now this input 2 has different cases, and from the input 2, this series of incidents will be there, and from that the input is used to form the input 3, and again input 3 have the lot of subdivisions which is used to form the input division will be combined to form the input number 5. So these interdependent variables, this is most important, these interdependent variables are combined to outcomes, or the outputs are dependent on the inputs. So we need to establish the relationship between what is the relationship between the output and the input, and that is being given with between the input and the output. Based on the inputs and outputs relationship, how we can able to arrive an outcome belongs to that. We'll have lot of subdivision interdependent activities related with each other. If it is happens, this will be the case. If this is the case, this will happen. But it doesn't have any subdivisions. If there is a body scanning, if it is metal, okay, it's a robot. Metal, then it is considered as a human. That's it. So this is the logic which we have to combine across all sort of stuff. But the case which is here is completely different. In this case, everything will be interlinked. Has to define the output. Suppose when I want to convert this, if it is a robot, it is 1. If it is a male body, male human, it is 0. Again, if it is a female body, divided it, right? So that is the logic. Again, if it is a breath rate, you don't have this as this condition, you cannot convert this into causality. But here in this case, you can convert into this ordinary inputs and outputs can. The outputs are defined with a model called regression. The casual AI is nothing but it is an AI which can be have the interdependent inputs which has the impact. This inputs has its own impact on this, and this has its own impact on this, and all these things put together, we have the outcome of the movie. So this is the logic of a causal AI system. So how it is be defined, guys? It's clear what is this causal AI, what makes the difference between this and the traditional AI and causal AI.
Yes, sir, it's clear.
Yeah. So this is being particularly utilized in this logic which we have to utilize for this. So now, so how to make it this? How to make it as an right? We have Python code and everything, but in any point of view, you can see it is a graphical representation. Right? So this is the thing which we have to define it. So graphical representations need to be taken. So whenever you have a data, we will be converting into the graphical model, and from the graphical model, we will be designing with the mechanism. So let me have a case study first. Let me have the case study for this causal AI. So first is, so there will be hanging actually systems. Sorry, there was a hanging in my system actually due to the softwares. So graphical model. So let me have an example for you. This is something called influential nodes, or this is a case study number one, right? So this is the logic actually. So what do you mean by the influential node is, I'll tell you the problem which has been there and how this causal AI has been utilized. So you may have come across the lot of fake news in Twitter, and particularly in Twitter and all the social network. You can see something of fake networks and everything. Can you identify the source of the fake network, that the fake news which has been started its own source? That is the source of the fake network where it has been originated. So this is known to be called as a influential nodes. So we have these two categorization. Influential node, who has the node or a user who has the influential on that particular group or a particular network. So in order to identify this, we will take a lot of parameters, that is a number of messages, the interdependent messages, the time of staying there, the timestamps, right? And parallelly, we have a lot of things when he, the in time and out time, timestamps, in and out times actually, and a lot of things which has been happening over here, all timestamps and everything. And moreover, what category of messages he made over here, right? And these are the things which has been taken into an account. Now these are all the dependent because of the scenario, and we have to consider the environmental also, environments also, where does and how does these environments, and based on that we can able to identify who is the fake, or who is the fake, or who is most influential. So influential in sense, who is occupying and who is creating a lot of newses and who has control over that network. Or fake is something like creating the nodes which is creating the fake newses. There is a difference. So what I can do here is all these things are considered. So the time in out time, let us say like I have an intern of 12:34, and then we have this out time as 3:40, and then the time gap is 3 hours, and then number of messages what he posted is something on 39, right? And we need to identify the mechanism. Now this, all this data will be converted into the graphical mechanisms. This is the most important thing. So graphical models, and then it will calculate the edges of inputs and outputs. Edges of inputs and outputs will be decided, and the relationship will be derived based on the inputs and outputs. And then finally, we will be deriving what is the outcome. This is the logic. So everything will be graph oriented. So everything is a graphical model. So in order to identify, this is one case study which you can make it an understandability that it is to understand, it is to make it that one node, that is one node who is been occupying the may occupying or has an influential on the other nodes. How to identify this? Who is the case? Who is that? So list out all the messages and all the user IDs, timestamps, and everything. So we will convert all this pictorial thing into the graphical mode. From there, we will be converting into that edges, the connection of edges, right? So for example, if 1234 to and 1234 to 234, one guy up to like 780, and he's spending like 5 hours, and he has sent some like 763, right? So now the logic is how much node he has been connected in this 3 hours. Let us say these nodes are connected with the users which is represented at 19. If these nodes are connected with the nodes of 45, then he is considered to be the most influential model. So the input and the edges which is utilized to connect with each other. So the relationship is being derived based on how much nodes are being connected for a particular time. That is in and out edges. That is being decided to decide the outcome. That is being decided the outcome. So these all these features based on the in and out edges of your nodes decides the outcome, who is the influential mechanism. So this is the logic of the basic understandability of your causal AI. This causal AI networks is this something like all this traditional doesn't have this. When we have to understand two important things. One is like in the traditional AI, we don't have this kind of causalities. That is the subdivision of the inputs, which is all interrelated with each other. Subdivision of inputs which are interrelated with each other. It's not been deal with the traditional AI, but here in causal AI, we need to take over it. So the causalities which has been going to take over, what are the things? In best example, next best example is your plan of savings. This is the most important. So why do we take insurance? Why do we take a savings plan? Why do we take an FD? Why we take an RD? Why we want to make it in the post office? So all these things are being decided based on the outcome what we have, what the outcome has to be achieved. So this is known to be your causal AI system. This is a causal networks where it deals with lot of inputs, lot of things, a probability of inputs. If this happens, what will be the case? If this happens, what will be the case? Here, if the edges, if this is the 234 and 340, like this is spending a 3 hours in a time, and he has posted nearly 1039 messages. He is spending 3 hours and 1039. And again, I'm just saying, if he spend this 2 hours, what is his message? If I spend it for 5 hours, what is his message? So this is how we made it over here. So I can see through the graphical representation. How to visualize? That is being seen through the graphical representation, and that is being identified with the interaction of the nodes what we have. So these nodes will clearly give you the picture about the possibility or the probabilities which is being taking place over here. That is probability. This is what has happened. If this has happened, what is there? If this is not happened, what is there? So everything will be defined in the nodes itself. So that is what I told you. Example, the in and out conditions. It can monitor